Our goal is that we'll be learning about Arbitrum Stylus. So Arbitrum Stylus is a multi-VM model where you can write smart contracts in Rust or C++ and they compile down to WASM, and they are interoperable with Solidity as well. So before that we'll just learn how Nitro works. So Arbitrum Nitro is the main component of how Arbitrum works. So we'll first learn about Nitro and then we'll continue from there. So okay, so Ethereum is good, but since the throughput is not good, so we need rollups for that. And Arbitrum is one of the optimistic rollups that does that. So we only have 20 to 40 PPS with Ethereum, but when we come to optimistic rollups, we can actually increase the throughput with all the algorithms. So how it works, I'll explain the mechanism. So first we there are 4 components. So sequencing and execution. So instead of using every one of the transaction one by one, so we use a sequencer which takes the input of all the transactions, sequences it, and posts it on the L1 as well as the proving mechanism. We use geth is for all the execution, and a dual compilation and interactor. So I'll actually explain the. Yeah, so what happens is we have a bunch of transactions and then we have a sequencer. The sequencer arranges all the transactions and it posts, it creates 2 sections. So the batch and compress algorithm, it puts all the sequence transaction to the L1 chain, which is the mainnet, and these sequence transaction also go through a state transition function. So we have since Ethereum is a state machine, so we have a state transition function. We have sequence transactions, and every transaction one by one is put it in the machine. The state updates, and after all the transactions are through, the block is created, and the batch and compress algorithm, whatever transactions are sequenced, they are posted on the chain itself. So what is the purpose, why are we doing this 2 times? So think of it like this. So maybe this is the transactions that you are going through, you are doing, they are posted on L1, and at the same time the sequence transaction will go to the straight transition function. They'll create the final state that should be there, and the final this computation, the final state will be posted to the L1 itself. And then there's a fraud proofing mechanism, and then anyone can dispute that. So one of the analogies that I use is so say someone is trying to bake a cake. So this data that is posted on the L1, this is all the ingredients that should be put into the cake. This process is actually creating the cake, and you can see what ingredients were there, and after the computation the final output is there. And if anyone wants to dispute that, he can use all the ingredients, run it through all the processes, and see if the final output matches or not. So if it doesn't, then anyone can dispute that, and then through the fraud proving mechanism we resolve the dispute, and then it moves forward. So this is the general cycle. Yeah, so this is all how it works. So in the phase 1 there is sequencing. So this is the real time feed for all the transactions that are happening. Then the transactions are compressed in a batch, and they are posted on the L1 chain, and it is a censorship resistance as well. So and then the execution is as I explained. So all the transactions are bundled through, they go through the transition function, and state is updated, and then they produce the Ethereum compatible blocks, and the updated state is posted on the chain. Yeah, so first arrow was the batch and compress. So it takes the order transaction, it compresses them, and it puts it on the L1 chain, and then the settle to L1 is actually posting the result after the transitions. And yeah, this is actually like the analogy I explained. And yeah, so this is clear to everyone, right? Okay, okay, so then we like see what the architecture looks like. So the software it has three layers. So the base layer is the core layer, the geth layer, which performs all the EVM execution and the state management. Then we have the ArbOS layer. So the ArbOS actually, so the batch and compress algorithm that we discussed was for the ArbOS. Like it performs all those operations for compressing and posting it on chain, and then the node software, like it handles all the RPC and all the Ethereum compatible like operations. So yeah, you can. Yeah, so this is the get sandwich as it like talks in the paper. So we have ArbOS, we have the get core, and we have all the node functionality for like RPC handling and everything. Then this compiles to the native, and we can run it as a node. And the compile to WASM, I'll explain what it is like. So. Yeah, so like these are the core ideas. So it is powered by geth, and the deterministic execution actually means that okay, all the transactions are going through the state transition function, and the final state will be the same for everyone. Then the separate execution for proving is that the second section, like the proving mechanism, is for like dispute resolving and everything. And yeah, it is a optimistic rollup with fraud proofs. So yeah, now I'll explain how WASM comes into play, and then how we move to Stylus, and we start building for like the Rust contracts. So the state transition function that I explained. So the WASM, how it works. So yeah, so what happens here, when the process, it compiles down to the native code, like natively, as well as in the WASM binary. So the WASM binary, it actually is for whenever someone raises a dispute or something. So the WASM binary is used, and one by one we dissect the proof. Wherever the fault happens, we resolve that and then move on from there. And this is like actually the protocol, how it works. So this is the complete flow of a transaction on how it happens. So there's the rollup block creation with all the L2 block data. Then there's a challenge period. So after the data is posted on L1, and after the state transition function has happened and L2 block is produced, there's a challenge period for 1 week. So if anyone finds a dispute, like if anyone finds any inconsistency, he raises the challenge for it goes on for the week. Then the dispute resolution happens. So like we go over blocks, then over instruction, then one step proof, and the outcome is that if someone is like cheating, so the half to the winner, whoever is raising the dispute, and half to the public goods. So yeah, so now we move on to Stylus. So this is how Arbitrum works, and since WASM is at the core of Arbitrum, so why not use the WASM binary just to write contracts? Because if right now, if you're only writing in Solidity, why not use Rust and C++ and other languages to write contract, and it compiles down to WASM, and then we use those contracts for like interoperability. So it has a multi-language support. You can write contracts in Rust and C and C++, and it remains operable with Solidity contracts as well. Why do we need to do that? Because so if you're writing a cryptographic library which takes like a lot of time and much more execution, why not write in Rust or C, and you can have a execution like very fast and with much less cost, and it is like fully compatible with EVM as well, so there will be no interop issues. Yes. So right now, like you write a Solidity contract, then it compiles to bytecode, then the Nitro executes that bytecode, and that's how like your smart contracts work. But what Stylus does is like it provides a multi-VM, so you can write contracts in Solidity as well as in Rust or C or C++, and the multi-VM, it can handle both the EVM bytecodes as well as the WASM, and the both contracts work interoperably. Yeah, so any questions till now? Like this is like generally what Stylus is, and after that we can like actually see how we work with Stylus and start building from there. Yeah.
You mentioned the geth sandwich.
Yeah, yeah.
In which ArbOS.
Yeah, yeah.
You said is where the compilation of the code from Stylus happens.
Yeah, yeah.
The finality is the L1.
Yeah.
Yeah, but how you achieve this kind of 70x, 100x performance?
So you mean like how?
Example,
Yeah.
I read somewhere if you call SHA-256
Yeah, yeah.
in Stylus, instead of use the recombine, it's like 70x performance increase. So where is
So yeah, like when you're writing, so maybe like you're writing Poseidon in Rust, so why not use that? So WASM is like Stylus. It allows you that you can write Poseidon in Rust, and it compiles down to WASM, and the multi-VM architecture I explained, it handles that WASM binary, and you can actually interoperate with like the EVM bytecodes as well. So instead of writing Poseidon in Solidity, like I don't know how I'll write, so it will be like very expensive. So why not just write in Rust, and Stylus provides you the compatibility to speed up that, because like WASM binary, its opcodes are not that expensive like compared to like the EVM bytecodes, and so I'll explain that later, but like how gas metering works. So for one gas of Ethereum bytecode, like it is like 1000 inks or something. So you can perform 1000x more operation with the ink instead of like the EVM opcodes. So that's where the that performance gain happens.
okay? You combine it with your machine, right?
Yeah.
Infrastructure, and that generate a kind of binary. And
Yeah.
the ArbOS uses like a hook and use run it. But how that mix with the bytecode? It's like I don't understand that point. Where the combined code from Rust and the bytecode from Solidity
Yeah.
together.
Yeah, we'll come to that like later when we work with the Stylus. So like when we start writing contracts in Rust and then compile it to like WASM and then execute on chain. So we'll see there like how it is much more efficient. Yeah. Yeah.
We're talking that we're using Rust, let's say cryptography libraries in Rust.
Yeah.
They use default federation. RPM for EV acceleration or no?
So can
Okay.
yeah.
We are talking about using Rust for performance, right?
Mhm.
A lot of cryptography libraries use GPU acceleration because it's really like heavy doing the computation. So
Mhm.
does the VM support that? Because if it isn't the case, how much performance are we getting just for running normal Rust code without GPU acceleration?
Yeah, so actually it's the multi VM itself. So like if it can handle both EVM plus WASM, there's like where the difference comes into play.
Yeah, but my Western binary is able to do like multi-thread GPU acceleration, or is only running that in one thread?
I'm not sure about that. Maybe like we can check it that later, like if it performs or not. Yeah.
Okay.
Okay. Okay. So, okay, we can move forward. Yeah. So we'll actually just follow the like Arbitrum docs and the stylus docs for like setting up everything. So okay. Ah, fuck. So yeah, like for setting up, we'll just follow the docs. So if I like these are the prerequisites that you should have on your like system. So you should have a like Rust compiler running. I hope you're using VS Code or Cursor or anything. You should have Docker and Foundry and
Can you
the
please zoom in?
sorry.
Or what? Zoom in.
So, yeah, okay.
Or what's the name?
Yeah, so I hope everyone must be having Rust and Cursor and so yeah, we need Docker as well because like we'll run it locally, the Nitro dev node, and we need Docker for that. So for dev node, like you can actually just follow the quick start guide and yeah. So should we like set it up? If yeah, like are we good? Like, so we can, if you have everything, then we can like run start setting up and then see how it works. Okay. Yeah. Yeah. Okay.
In the Arbitrum quickstart. Arbitrum docs quickstart.
Are you on the Discord? I think I'm not on the. Yeah, I'm not on the Discord as well.
Which channel? Okay. I'm not sure. See, I'm on
Yeah, no. Yeah, I'm not on the Discord.
You can write it on the whiteboard. Why
On the blackboard?
on whiteboard?
Oh, I'll just ask. Yeah. I think I'm not on the Discord, so you can just follow the link. I'm not sure if everyone is even following the quick start.
No, sure.
Yeah, I don't know.
Let me ask more questions. Ask a question. Ask if any questions or
Yeah. Is everyone like set up? Are we following the quick start? Oh, okay, okay, okay. If there is any issue, you can ask or. No? Okay. Yeah. Oh,
We just have to follow all the
okay, okay.
that's what we're doing now, right?
Sorry?
What we're doing now is just like following the quick start.
Following the?
The quick start.
Yeah. I don't know if everyone is following the quick start. Yeah. Yeah. So like if you set up, then uh, if like everything is installed, then like this command should work, and we can then move on to installing dev node as well, and then start running it.